Hello kids. This is Sir Mac. Electromagnetic induction, also known as the generator effect. Let's suppose we have got two magnets with a magnetic field. If I take a wire and move it like this in the magnetic field, we can observe that there will be a potential difference or EMF that is present. This induced EMF is because the magnetic field lines are cut by the conductor. If a conductor cuts the magnetic field lines of a magnet, it causes a change in magnetic flux. Therefore, an EMF is induced. You can clearly observe that when the wire stops moving, for example, at the top and at the bottom, the EMF disappears. This shows that when the wire is cutting the field lines, only and then the EMF is there. Instead, if I move the magnet up and down, there will still be an EMF because the magnetic field lines are still being cut. Let's observe this phenomena in a completely different manner. If I take a circular coil and insert a magnet inside that coil, the magnetic field lines of the magnet will be cut by the coil and EMF will be induced. When the magnet is stationary in the coil, the EMF will be zero because at that instant there will be no cutting of field lines. Now I am pulling the magnet outside. While the magnet is pulled outside, again there is a cutting of field lines, therefore an EMF is induced. We can measure this induced EMF with the help of sensitive center zero meter, also known as galvanometer. If I need to increase the amount of EMF that is being induced, I can do three things. First, I can use a stronger magnet which will have more field lines. Second, I can increase the speed of the conductor or the magnet. Third, I can use more turns in the coil. These are the three ways which helps to increase the magnitude of the induced EMF. Let's talk about Faraday's laws of electromagnetic induction. Faraday states that the induced EMF is directly proportional to the rate of change of magnetic flux. In easy words, the more cutting of field lines, the more EMF is induced.